You say that I'm paranoid, but I'm pretty sure the world is out to get me. It's not.
And now I'm going to do the part 1 of lab E2. So from this circuit, as you can see that I'm making the green wire as my D input and the blue wire as my clock input. So let's start from, from this graph, first of all, the D input and the clock input are 0, so the LED doesn't light up. And from here, the D is 1. And yet, the LED doesn't light up until there is a clock input. So as you can see from here, the LED lights up. And then, slowly, from here, the D input becomes 0. And yet, the LED lights up, as shown here. And then, there is a clock. The LED switches off. And then, moving on, here, there is a D input again. But yet, the LED doesn't light up. And then here, the last part, the D is 1. Okay. And yet, the LED doesn't light up. And then, there is a clock input. The LED lights up. Thank you. And now I'm doing part 2 of lab E2. So first of all, as you can see in the schematic diagram, our clock is set to 500 kHz. Yes. And then coming back to the schematic diagram, the Q bar is connected to D, whereas our Q is our output. Okay, so moving on to our waveform. This is the expected waveform that is going to produce. Following here is the same. And also for the frequency at the waveform X, which is the output, we can see that it is 250.0 kHz. That's all. Thank you. Hello, I'm Melvin. I will be demonstrating part 3 of the lab. It is a 4-bit synchronous counter so that it will count from 1 to 6. And this is a K-map for the reload logic so that it can count from 1 to 6. This is the circuit design. And now we will proceed to the circuit. At first, it already showed the output as 1. So now we will show the output from 1 to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it will show all the range of from 1 to 6. And the question asks whether it can stop at 6 when the run stop button is low. Let's wait until it's 6. Yes, it can stop at 6 when the run stop button is low. And the question also requires us to produce a random number covering the full range of 1 to 6. In order to do so, we'll increase the frequency. Six, 2, 2, 2, 4, 6, 1, 5, 2, 2, 1, 2, 4, 2, 1, 3.
Hi, my name is Vicky. Today I'll be talking about part 4 and 5 of our lab E2. As you can see here, we designed a decoder circuit where 3 binary numbers are also input to produce 4-bit output for our die display. So moving on to our care maps, we designed our circuit using our care maps right here and implemented it to our circuit right here. As you can see, the die is at now input 1. So we have input 2, 3, 4, 5, 6. Similar to that of our lab display here. So moving on, we will check whether our numbers right here will stop at 6. So I will set it as it's on. Okay, 3, 4, 5, 6. Okay, we have it. It stopped at number 6. So moving on to our part 5, we'll check for random numbers. So we set our frequency to higher, which is about 2 kHz. So checking for random numbers, we'll have 6, 5, 4, 5, 5, 1, 3, expecting a 2, and 1, 6, 3, 2. And that's all. Thank you.